video is about linear and angular velocity. And so this is what the concept is. If you think of a point on the edge of a circle and with a radius r, if that point is traveling around the circle at a regular speed, at a uniform speed, then it's covering some distance. And the arc length that it covers is s, and so it will sweep out this angle theta as it travels around the circle. Well, the speed at which it's going around the circle can be thought of in two ways. One way you can think about it is how much physical distance is being covered. Like if you measure this arc length, it would be measured in something like centimeters or inches. So if you take that distance over time, that is the rate at which it's traveling, and that is known as the linear velocity, the distance traveled per unit of time. The variable given to linear velocity is v, and so it's known as, the formula for it is s over t, where s is the arc length over some unit of time. It could be minutes or seconds or hours, just some unit of time. Similarly, what is angular velocity? Well, we see this angle theta that's being swept out as arc length goes around, and it's kind of the rate at which it's cycling, how many angles, how many degrees or radians it's going through per unit of time. It's the central angle swept out per unit of time. So that's how you can think about angular velocity. The variable given to angular velocity is the omega symbol, and so omega is defined to be the angle theta divided by time. Now, both of these formulas have to be in radians in order to use them. So your calculator needs to be in radians when you're talking about this angle. They're not cooked up for the degrees. It's just people have decided to use radians for this, and so these always must be in radians when we're using these. So what did I put in here? This is kind of how you can think of this. Suppose that a point, here's some point on a point is moving with uniform speed on the circumference of a circle with radius r. If the point moves an arc length s, then a central angle of theta is swept out. So this is kind of the visual of what we'll be using throughout these problems. I'm going to erase this and leave these two formulas, which are also on your sheet, just so I have room to do some problems. And we're going to develop another formula that's commonly used just through a bit of algebra. So this is how we can, and then we're going to do these 5 little problems as examples of linear and angular velocity. So I'll leave these formulas on the board. I want this space. And then I'm going to show you how we can come up with another formula using some algebra. So arc length has been defined earlier in the course as s is equal to r theta, and so it's radius times the angle. So if we look at this linear velocity, and instead of writing s over t, we write it as r theta over t, then we can think of that as the radius times omega, theta over t, which can equal to r times omega, because that is what omega is defined to be. So sometimes we say v is equal to r omega when it's convenient, and sometimes we talk about it like this or this. So we're going to be going through these examples, and we'll come across a few things that maybe we haven't heard of before, and we'll discuss those as we go. All right, so have your calculator handy, and we will dive into this. It says if a 3-foot diameter wheel turns at 12 radians per minute, what is the velocity of a point on the wheel in feet per minute? So right here, number 1, it says that there's some wheel. So draw yourself some kind of a circle. Just do your best. I'm doing my best. There it is. There's my circle. Okay. And it says it's got a diameter. Some wheel has a diameter all the way across. The diameter is 3 feet. And it says the wheel is turning at a rate of 12 radians radians per minute. When I hear those units, that is telling me radians is a measurement of angle per time. Angle per time is angular velocity. That is telling me what omega is. That's what they gave me. And then it says, what is the velocity of a point on the wheel in feet per minute? What is the velocity of a point on the wheel? So here's some point on the wheel, or here's some point on the wheel. What is the speed at which that's traveling around? And the units are in feet per minute. And so this unit is telling me that is a distance per time, and that is the linear velocity. The velocity is what in feet per minute? So this is what they told me in the problem. This is what I'm looking for in the problem. So here is a way we can go about solving this problem. First, they gave me diameter. I must know that I don't have a formula with diameter in it. I do have a formula with a radius in it. So let's figure out what the radius is in case we have to use that. So the radius is equal to half of a diameter. So the radius is 1.5 feet. Okay, we're looking for velocity, and velocity is equal to S over T, and it's also equal to R times omega. Oh, okay, I'm just going to use this because what they gave me in this problem was omega. So velocity is equal to the radius times the angular velocity. So the linear velocity, V, is equal to the radius, 1.5 feet, times the angular velocity, which is 12 radians per minute. And so we're going to multiply 1.5 times 12, and that's going to give us 18 feet per minute, and that is, and so we don't write the radians because it's understood to be in radians, and we don't usually write that down. So this is going to be the units for our linear velocity for number one. Okay, number two goes like this. Number two, they say a point on the rim of a 4-inch diameter wheel is traveling at this rate. So what do they tell us? Here is a wheel, okay? And they say it's got a diameter all the way across of 4 inches. 4 inches, okay? And it says it's traveling at 88 feet per second. So the units tell me everything. Is that an angular velocity or a linear velocity? That is linear because it's a distance per time. So what they gave me was V, 88 feet per second. So some point here, some point on this curve is traveling at this speed. What is the angular velocity of the wheel? And so they want to know what is omega, and they want to know what it is in radians per second. This is what they want the units to be. Okay, let's see what we can work with here. For this problem, they gave us the linear velocity, and we're trying to find omega. And so I'm probably going to use this one again, that V is equal to R omega, because they told me V and they told me the diameter, which I also know R, and I don't know this. So this is a convenient one to use. I can solve for omega. If I know that V is R omega, I can just divide both sides by R and get this. Omega is the linear velocity divided by the radius. So that's going to be 88 feet per second divided by the radius. Now again, they gave me diameter, so I got to change to radius, which is half of that, which is 2 inches. But there's a little bit of a conflict because this is in inches and that's in feet, so I must do a conversion here. I'm going to convert the, what did they want it in? They just wanted it in radians per second. So either I need to convert 88 feet into inches, or I need to convert 2 inches into feet. I'm going to choose to convert inches to feet. So I'll say 2 inches times there are 12 inches in 1 foot. And so I put what I want to go away in the denominator, so those cancel out. So there is 2 can go into 12 6 times. So 1/6 of a foot is equal to 2 inches. So I'm going to divide this by 2 inches, which is the same thing as 1/6 of a foot. This is how I would do it mathematically. 88 feet per second times the reciprocal, 6 over 1 feet. So divided by 1/6 is times 6 over 1 feet. These feet will cancel, and so 6 times 88 gives me, I'm not sure what that gives me, I'll use my calculator. And I get that omega is equal to 528, and this is in radians per second. And we know it's in radians because we're using these formulas, and it has to be. Okay, so that is number 2. Let's look at number 3. Number 3 says, if an 8-inch diameter wheel shaft in a boat is rotating at 350 RPM. So what is RPM? We haven't come across this yet. RPM means revolutions per minute. So that does not give us an angle measure, it gives us a revolution measure. So sometimes they will talk about angular speed and revolutions, and what we have to do is convert that into an angle measurement, okay? So let me put this last little formula that I just erased back up here. V is equal to R omega. That's what we just figured out. Okay, cool. So number 3, if an 8-centimeter diameter drive shaft, so here's my circle. Okay, that's my circle. Okay, this is number 3. Let's see, in a boat is rotating at 350 RPM. So there is some, here is a center, it's got some radius, and some point on the end of this, it's rotating at a rate of, oh no, this is the linear speed. So let's see, the angular speed right here, omega is 350 RPM. But this needs to be converted, right here, this needs to be converted into angles. So it needs to be converted into angles. So what I mean by that is RPM means revolutions. The revolutions, how many times it goes around per minute. Okay, so we're going to convert revolutions to angles. That's pretty simple. And then it says, what is the speed of a point on its surface in centimeters per second? So they're asking, centimeters per second is distance per time. So they're asking us, what is V? What is the linear velocity? And it says round to the nearest tenth. So we've got to find V. They told us omega. Okay, and did they tell us anything else? Oh, yeah, I skipped this. The diameter is what? Okay, the diameter is 8 centimeters. So what would the radius be? The radius would be 4 centimeters. So we know R, we know omega, we can solve V. So we should use the same formula again. V is R omega, but the only problem here is there's a little bit of converting we need to do. This was given in revolutions per minute. So let's talk about a revolution. If I'm on the edge of a circle and I go around 1 time, that's 1 revolution. If I go around 2 times, that's 2 revolutions. So how many degrees do I go through in 1 revolution? I go through 360 degrees. How many radians do I go through in 1 revolution? I go through 2 pi degrees. So 1 revolution is equal to 2 pi radians. 1 revolution is equal to 360 degrees, but because these need to be in radians, I'm going to just talk about this. So let's convert this. If this is 350 RPM, that is the same thing as 350 revolutions per minute. Well, how many radians are in 1 revolution? there are 2 pi radians in 1 revolution. So to convert this omega into angles per time, you just multiply it by 2 pi over 1 revolution. This is going to be, let's see, that's 700 pi radians per minute. So you can write the radians, or you don't have to write the radians, but that is what omega is. So now we can just simply say, well, what is the linear velocity? It's going to be the radius, which is 4 centimeters, times omega in radians per minute, 700 pi radians per minute. Now let me see. Did they want it in, they wanted number 3, they wanted it in, seconds. So I got to do another conversion. So let's go ahead and figure out what this is. Let's see, 4 times 7 is 2,800 pi centimeters per minute. This is the linear velocity, but they asked me 2 things. They said, put it in centimeters per second, so I have to do another conversion because this is in minutes. And then they also want me to round it to the nearest tenth. So to convert I'm going to write my fraction like this because this is called dimension analysis per 1 minute. So I'm going to watch my units cancel out. How many seconds are in 1 minute? In 1 minute, there are 60 seconds, right? So these will cancel, and I will take 2,800 pi divided by 60, and that's going to give me about 146.6, and this is going to be in centimeters per second. So if I round to the nearest tenth, when I put that in my calculator, that's what I should get. I'm going to double check just to make sure I haven't written something down wrong. Let's see. 2,800 pi divided by 60 gives me, 146.6 centimeters per second. All right, so we have 2 more problems. Number 4 says this. A space shuttle is placed in a circular orbit 250 miles above the Earth's surface. One orbit is completed in 1.51 hours. If the radius of the Earth is 3,964 miles, what is the linear velocity of the shuttle in miles per hour round to the nearest hundreds? Okay, so I'm just going to use the circle that I have drawn here, and we're going to let that represent the Earth. No, I'm going to draw the Earth inside of that one. Okay, this is number 4. Okay. Number 4 says a space shuttle is placed on a circular orbit 250 miles above the Earth's surface. Okay, so let's let this be the space shuttle. All right, so let's let the Earth be some other circle in here. This is blue and the Earth. So here's the Earth's radius, and they said that the Earth's radius is, this is not the scale, of course, 3,964 miles. That is the Earth's radius. And then it says 250 miles above the Earth's surface is the space shuttle orbiting around. So that means that this distance to here is 250 miles. That's what that means. Okay. And then it says one orbit, one time around, is completed in 1.51 hours. One revolution is completed in 1.51 hours. Okay, but we can, this is another way of talking about angular velocity. We can convert this very simply by saying, okay, let's convert revolutions. 1 revolutions, how many degrees, how many radians are in 1 revolution? 2 pi radians. So real quick, the omega is 2 pi over 1.51, and the units are radians per hour. Now, what did they ask me to find? They asked me to find the linear velocity of the shuttle in miles per hour. Okay. The linear velocity is equal to r times omega, and they wanted it to be in miles per hour. Okay. Miles per hour. Okay. This is what we don't know. Now, let's just see if we have to convert anything. We need it in miles per hour. The radius is the radius of the shuttle, so it's going to be 3964 plus 250. That's going to be our radius, and it's in miles. The omega is in per hour, so we don't have to convert that. We're good to go. We just say the velocity is equal to the radius. So if I add these two numbers together, what do I get there? If I add those two together, I get 4,214 miles times 2 pi over 1.51 hours. And so this is going to give me miles per hour is my units, and it's going to give me, what do I get there? I get in 17,534.7 miles per hour is what we get for our linear velocity. Now, they said to round to the nearest hundreds. Not hundredths with the TH on the end, which means to 2 decimal places. This means to the hundreds place. So if I'm going to round this to the nearest hundreds, 5 is in the hundreds place, I'm going to round down. So we'll say it's traveling at about 17,500 miles per hour. That's how you can do a rounding for that. Okay, last problem, number 5. This is about a wind turbine, and it says a wind turbine has propeller blades that are 5 meters long. If blades are rotating at 8 pi radians per second, I hope that you're beginning to hear 8 pi radians per second is an omega. It is an angular speed. What is the linear velocity of a point on the tip of one of the blades? So let's do number 5 here. They give you a little picture of a turbine. And it says the blades are 5 meters long. So that is telling you, if it says the blades are 5 meters long, that's telling you that the radius is 5 meters long. Because if you see the picture of our wind turbine, let's just say those are the blades and that this is it standing up. The blades are going to be the radius of the circular motion that it would make. Okay, that does not look like a circle. I'm so sorry. Maybe that's a little better. Okay. But the radius is 5 meters. And they're rotating at, so omega is 8 pi radians per second. Okay. What is the linear velocity of a point on the tip of the blade? So here's a point. How much ground is it covering? How much distance is it covering? What is V? V is what? Okay, well, here we go in. V is r omega. V is 5 meters times 8 pi radians per second. If we multiply all those numbers together, let's see what we'll get there. We will get 5 times 8 times pi, and we get 125 I'm going to round to the 10th place, 0.10 meters per second. And that is what the linear velocity is. Let me see if they asked it for it in specific units. No, they didn't. So that's just fine. Okay, so that is linear and angular velocity.